Hi, this is Matthew McMatherson, and I'm recording this video to share with anyone interested some ways that I integrated GeoGebra and JavaScript to help me make algebra problems to use in a geometry class. And I'm going to show you how I did that. And it starts with on my website. You would need to go to this link right here. When you click on it, a big page full of stuff is going to pop up. And you don't actually need to know anything about this stuff, but if you know JavaScript, you can sort of look over it. All you need to do is just highlight everything on here and copy it to your clipboard. Once you've done that, you don't need the website anymore. But what you will need is GeoGebra. So this is GeoGebra right here. I'm running version 4.0.32, which I don't think is the latest version. I think there's more recent ones that have been released. So that may make a difference. Anyway, so here's what you want to do. You're going to want to, up in the toolbar, create a button. And you can put that anywhere. And you can type whatever you want here. And after you've done that, once the button is created, you're going to right-click on it, go to Object Properties, and up here in these tabs, you're going to look for the Scripting tab. And then another set of tabs will show up, and you want Global JavaScript. And you're going to highlight what's already there and erase it. Now you're going to paste everything else that you just copied, which you can do using the Control-V command. And there it all is. And actually, not all of it will show up on the screen, but it's all there. Once you do that, you're going to want to hit OK and then close, just to be sure. So now that you've got all the background stuff in place, here are some things you can do with it. Let's say I want to make a problem where I have two segments. And I want to say that segment AB is congruent to segment CD. And I want to make an algebra problem that they have to solve, or my students would have to solve. So now if I right-click on button, and I go to Object Properties, again I'm in the Scripting tab, again I'm in OnClick, and we're going to change this to JavaScript. And once we've done that, we're going to type in the function that we're going to use to generate this problem, which is generate problem one side. And then you're going to open up some parentheses. Oh, the capitalization matters. So notice how this is lowercase, but these are all uppercase, so it has to be the exact same. In the parentheses, what you're going to type in are essentially the names of the text boxes that GeoGebra is going to create. So I'm going to type in quotes text1, text2, and then in quotes answer text. I'm going to close the parentheses, and I'm going to type a semicolon. And I'm going to hit OK. I'm going to hit close. And now when I press the button, a bunch of text is going to show up right here. This is that answer text that we created. It generates the answer. This is text 2, which has the problem. And here's the other one, which has just the number, which has been randomly generated. So what I can do is I can put this number over here and put this number over here, and I now have an algebra problem for my students to solve. Segment AB is congruent to segment CD, and if they evaluate it, they should get that n equals -3. Now if I want to make another problem, I just click the button, and it generates a new problem. And I can keep clicking it, and it will keep generating new problems. Every time you click it, a new variable will be created, but if you're someone who likes using specific letters, you can add an extra argument here, and in quotes I can type X. Hit OK, hit close, and then it'll always generate with an X. And if I want to be even more specific, I can add another argument, like 35, hit OK, hit close, and what that'll do is it'll make this number always be 35. This is really useful for, I use it a lot, whenever I'm doing angles. Because usually if I have a bunch of parallel lines, there's only two angles I'm working with. So if I want to make a bunch of algebra problems, then I need one of the angles to always be the same. So this is one thing you can do. I'm going to go ahead and delete these text boxes. And let's say I want to create a problem where this is a variable and this is a variable, and the two segments are congruent. So my students will have to solve for the variable and then plug the variable back in order to figure out how long these segments actually are. So if I want to do that, I'm going to do a different function. Generate problem both sides. Notice the capitalization again. Then in parentheses, I'm again going to put text1, text2, answer text, close parentheses, and include the semicolon. These things can be whatever you want, and if you start getting more complicated with all of this, then and you have multiple sort of problems that you're generating, you're going to want to make sure that these are always different for each problem. Otherwise, it'll mess stuff up. So I hit OK, I hit close, I hit the button, and again I have my answer text, and now I have two variable expressions that when I set them equal to each other, they will evaluate where k equals 10, and if you plug k back in, both of them will evaluate to 13, which means both these segments would be 13 units long. One thing that's sort of tricky about algebra geometry problems is that in geometry you always want the evaluated expression to be positive, and the code will guarantee that the evaluated expression will always be positive. So in other words, whenever I regenerate, this evaluated will always be a positive number, even if the variable is negative. So if I plug this back in, this will be 10, this will be 10. And I can keep generating as many as I want. And again, just like the last one, you can add some additional arguments. I added 30 over there. And now the evaluated will always be 30. So whenever you plug this back in, it will always evaluate the 30. So those are two types of problems you can do. Here's the last problem. Let's say I have a segment, and I've split it into two pieces. And I want to create an expression where this piece plus this piece is equal to the whole thing. So in other words, segment AC plus CB is equal to AB. So if I want to do that, I'm going to erase all this, and I'm going to do generate problem combine. Because in algebra what's happening is you have to combine like terms. And again, I'm going to do text1, text2, answer text, close parentheses, semicolon. Hit OK, hit close. So now if I click this button, I should have an expression where this expression plus this one is going to be equal to this total, which is 32. So I should probably add another thing down here that says AB is equal to 32. My students would need to know that. So with that information, they would set up this algebra equation, and if they solved it and then plugged back in, they should find that AC is 14 and CB is 18. Or it might be the other way around. This could be 18 and that's 14. But those would be the two things that you would get. So if I want to generate another one, now I have that my total is 46, so I better change this. And when I evaluate it, one of these segments should be 6 units, the other segment should be 40 units. So that's how all the little functions work. So let me give you an example of how I've used this in the past. I'm going to really quickly create 4 parallel line algebra problems. And here's what I mean by that. I've got 2 segments, and for the sake of time, we're just going to sort of assume that they're parallel, and I have a transversal. And so if these 2 segments are parallel, there's really only 2 angles that I care about. There's all these ones around here. So I'm going to find one of those angles. Let's say that this angle is 112. I can change that by making the rounding to 0 decimal place. So this angle is 112. So I'm going to make 4 algebra problems, all revolving around 112 and its supplementary angle. So in here, I'm going to type generate problem one side. I'm going to call my first text block text A1, text A2, answer text A. Oops, sorry, I messed up. I need to have quotes here. Then I need to open the quotes again here. Answer text A. I'm going to make my variable a lowercase a. And so now the text is wrapped around to this bottom line. And then I'm going to have this be equal to my 112, which I don't put in quotes because it's a number. Now I'm going to take this line of code and I'm going to copy it using Control-C, and I'm going to paste it down here. And I'm going to change all the capital A's to B's. B. B. I'll make this a B variable, and I'll still make that 112. Now I'm going to do it again. And I'll make this a C, and a C, and a C, and a lowercase c. And now, instead of having it be 112, I want it to be the supplementary angle to 112. And I could figure out what that is, or I could just tell the computer to calculate it as it's doing the code. 180 minus 112. Now I'm going to copy this and paste it down here, and I'll put a bunch of D's. D, 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 lowercase d, and that. I'm going to hit OK. I'm going to hit close. And when I press this button, a lot of stuff's going to happen. I have all this text down here. So I'm going to sort of pull it all out. These are all my answer texts. So I can see that my a variable should equal a, and the angle should evaluate to 112. B should equal 28 and evaluate to 112. C should equal 10 and evaluate to 68. D should equal 13 and evaluate to 68. So here's my D expression, which is supposed to be 68. So I'll put that in one of the places that's supplementary to this angle. This is generated from one of my answer strings, which I don't need, so I'm just going to delete it. So I hit the delete key. Here's C, which again is going to be 68. So I'll put that in another place that should be 68. And I don't need this. I don't need the 112. B is going to be 112, so I'll put that in one of the places that should be 112. And A is also going to be 112, so I'll put that in one of the places that should be 112. And I'll delete the rest. And so, with a little bit of cleaning up, I essentially have an algebra problem, where if I told them that CD was parallel to AB and asked them to solve for A, B, C, and D, my students could do that. And all I would need to do is just sort of close my window like this, File, Export as a picture, and I'd be good to go. And then what's cool is I can bring this window back out, hit the button, and a whole new set of problems is created. Again, these text boxes show up, so I have to go through and delete those. But B is still 112. Maybe I'll move B up here. A is also still 112. Maybe I'll put A, I'll leave A where it is. C is still 68. So maybe I'll put that someplace where 68 should be. And D is also still 68. And now I have a whole another set of problems. And this is what I've done. And the code looks just like this. So, I hope this is helpful. If you have questions, feel free to email me. This is the first time I've ever sort of made a video, so sorry for anything that isn't pleasant. And I hope this helps some people. Okay.